Hello, I'm Todd, and welcome to ResearchPod. In 1996, over 2 decades after their discovery of how killer T cells recognise virus-infected cells, Peter Doherty and Rolf Zinkernagel were awarded a Nobel Prize for their contributions to the field of immunology. In 1997, Doherty was named Australian of the Year. Now, as an author of 8 books on topics as wide-ranging as tennis and chickens, Doherty remains a force to be reckoned with, as well as a voice of reason in the ever-changing world of science. In this illuminating interview with our sister company, Research Features, we discuss Doherty's remarkable journey, the global challenges of today, and ask what advice he'd give to young and upcoming scientists.
My generation was the first to go to university. I was pretty naive. I did know, though, that the one thing I wanted to do was stay at school and not go out to work if I could avoid it. And I was interested in the medical sort of sciences, but didn't want to be a doctor because I thought all the doctors did was sit around in rooms and listen to people whine about their health. So I decided I was going to be a vet and save the world because I'd been through a kind of religious phase by increasing food production. This is back in 1957, 56. Very different world. There was great optimism about science. And we thought we could solve a lot of problems with science, which of course we've done. So decided to go to the vet school and be a vet and do veterinary research on diseases of food-producing animals. Being an Australian, I didn't expect to win the Nobel Prize. We're very modest. You may not think so, but that's the saying of my childhood where I grew up in Queensland was basically the absolute opposite of American optimism. I mean, you'd say, oh, it's a beautiful day and we've had a great time. And then the sentence would end with, but you can't win, mate.
That sounds similar to where I grew up.
So, yes, it's English. It's English working class, basically. Yeah. And that's what Australia in many ways is. And also it's a very harsh country agriculturally, and a lot of people tried to make their living out of agriculture. There were tremendous failures with soldier settlement schemes after World War I and World War II, for instance. So there was a kind of sense that you could be doing well, but suddenly something would strike you out of nowhere and you would be crushed. Whereas America, which is such a verdant country with wonderful agricultural land, it's only recently they've started to encounter that with climate change. And they really don't understand what they're in for and what's happening, unfortunately. Australians, I think, have got a pretty good idea.
Going back to, you said that there was quite a lot of optimism around that time.
Yes. We'd come out of World War II. There've been enormous advances in World War II, not necessarily advances that all help people, but penicillin came out of it, and a lot of new technology, and there was a general sense of that science and reason would help to solve problems. And also, I think there was a general sense after World War II that we're kind of all in this boat together and that we need to work together. There was more of a collectivist view of the world. We saw that what happened in Britain with the election of the Attlee government and the rejection of Churchill. Even the United States was much more along that line. I mean, Eisenhower, for instance, wanted to introduce a national health system, but the big companies told him not to do it and they'd look after people's health. Well, of course, that didn't work out well. So a different world, much more, in a way, a realistic world in the sense of people have been through a terrible war, and an optimistic world in the sense that people had the sense things would get better.
And do you think that's different today in forming
attitudes around science? In the world of Donald Trump, it's hard to see it. No, I think there's been a considerable reaction against science, even though people don't realize how science has transformed the world. They don't connect the fact that they can get on a plane and fly anywhere, or that their iPhone can have them talking to anybody anywhere with science. Yeah. That's stuff that just sort of happens. And the respect for rational inquiry and reason and truth is not what it was. And a lot of people had aspirations to join that world that look for the truth about things as best we can find it. And that's been falling off. And then we have someone like Trump, who is simply a compulsive liar, commanding enormous loyalty. And I don't think we've seen a figure quite like that since the 1930s in Europe.
Going back to those global challenges, I guess, that were happening at the time, how can you see that science has sort of changed in being able to help address those global challenges?
If we look at an issue like climate change, given the limitations of what people across the planet can do collectively and can agree to do, and we've seen the limitations of real action on climate change in the sense that we're not really pulling back greenhouse gas emissions yet. We all realize the problem, or any intelligent person realizes the problem, but basically the COP meeting this year, which is supposed to be the organization that really keeps things moving, this was the first time they've actually acknowledged that fossil fuels are involved. So that's kind of depressing. So part of the solution has to be, I mean, we have to work hard to convince people to change, but part of the solution has to be to provide people with alternatives. So science, technology, rational inquiry, and acting on that has never been more important. But there's an important difference. The science that served people up till almost now has always improved their economic well-being, and from their point of view, improved their lives, providing more entertainment, better medicine. I mean, there's been enormous advances in human well-being through advances in medicine, and not just in the developed world. A lot of it has gone across to others in the poorer countries as well. What we're asking people to do now is to change the way they live in some senses, and also change what they value. And what we're forced to value in our capitalist economy is massive consumption of what is often useless crap. And we're asked to sacrifice. We're being asked not to drive around in a 4-litre truck, but to drive around in something more economical and less gas consuming. We're being asked to turn down the central heating and so forth. And I think that doesn't go over very well with large numbers of people. Also, technological changes happen with such rapidity. People have become very disoriented, I think. I mean, people blame, for instance, the political process in the USA for the change in the nature of work and the change in the nature of employment. But basically, it's not the politicians who've brought in online marketing. It's not the politicians who changed farming so that there are mega farms and many family farms have either been sold up or gone to the wall. It's not the politicians who've destroyed Main Street in country towns. It's actually people's own actions seeking cheaper and more convenient goods. But there's been a downsize there. It's diminished a lot of people.
And would you sort of maybe be able to talk me through in sort of general terms the work that you were doing when you received the Nobel Prize?
We made a big discovery back in 1973, 74, and the Nobel Prize came 22 years later, which is not an unusual interval. Very common to wait 20 years. There are a few prizes that are faster, but the Swedes like to get the Nobel Prize right, and they don't like to make a mistake, and they made a few mistakes in the past, so they do wait. Well, the discovery, we discovered that the killer T cells, which are the white blood cells that go round and round in the blood, bump off cancer cells, as we now know from some of the therapies, or bump off virus-infected cells. Viruses grow in our own cells. You have to kill off these virus-infected cells, which are the factories that produce new virus particles. So these killer T cells bump them off. So that's what we'd found, and then we spent the next, I spent probably about from 1973, 74 till 2010, researching that with lots of bright young people in laboratories in Australia and in the United States. And in the United States, in Philadelphia, at St. Jude, at the Wistar Institute, and at St. Jude Children's Research Hospital in Australia, at the Australian National University and the University of Melbourne, where I am now. I trained people, we moved the field forward, but that big discovery that we made back in the 1970s, which actually overturned our understanding of about half of immunology. Of course, you only hit one of those in a lifetime if you're lucky. Luck is a big part of it, being in the right place and being lucky.
Yeah. Just picking up on something you said, you just said the Nobel Prize system is quite thorough in picking out any errors and with fact.
The science prizes, yeah, absolutely.
Yeah. Nowadays, we have tools like AI, technological tools that can fact check. I was just wondering about your thoughts on how that's sort of developing.
I'm not contemporary enough to really be able to speak with any great degree of insight about AI. But clearly AI has all sorts of applications, and I think rightly some of them are quite terrifying from the point of view of jobs, and also from the point of view of used badly for individual freedom. So it's not an area that I comment on because I'm not really into it enough. But I do think that we need very smart people who understand it to be setting some guidelines and rules. Whether those guidelines and rules will be obeyed is another matter.
You said you worked with lots of different bright people on your team. What was your sort of approach to collaborative work back then?
Different levels of collaboration. For instance, bright young people come into the lab because they want to train with you. They think they're going to learn something from you, and they do. And you've got the benefit of knowing a particular field, experience. And of course, you bring in under the sort of systems I've worked in Australia and New Zealand, the principal investigator, which is someone like me, brings in the money by writing grant applications, often with help from younger people. But on the other hand, it's a two-way street. So they get that benefit, you get the benefit of working with, because people at my level and people who are leading a reasonable sized program, there may be 10 or 20 or 30 people in that program. I never work with about more than 12 or so people. That was more than enough for me. But they're not working at the bench. They're not doing lab experiments, even though I'm an experimentalist. And so the young people are doing the lab work, getting the data together. You've got to sort of train people to write it up and think about it. My advice to a young scientist is always don't move on too quickly. Look at the data you've generated, try and understand it, live with it, sleep with it. Forget about personal relationships. No, not true. I mean, you've got to have a life as well. But love your data, live with your data, and really look at it closely and try to see what it's telling you. Because biology, biomedicine particularly, so complicated. If you put together the complexities of the human immune system, which are massive, and the complexity of adding a virus, for instance, into that, you've got an extraordinarily complex system. And biological systems, because they've evolved, are not like physical laws. They're not like the laws of physics. They do unexpected things. They find unexpected pathways. So you've got to be very alert to possibilities. Look for the odd result. Look for something that doesn't quite fit. Maybe your thinking will change and maybe you'll find out something new. I think a lot of people coming into science really don't get the point that unless you're in, say, developing a drug through from discovery to use, which is another perfectly legitimate area of science, which requires specific expertise and so forth. But if you're in the discovery business, it is about finding things. Yeah. And you must expect to get things wrong. In fact, you hope your ideas are going to be a bit wrong. Otherwise, you're not going to discover anything, right? Too dogmatic or locked into things in biology. Molecular biology was, for instance, really started by physicists, including a number who became disillusioned after the nuclear bombs. Physicists coming across into biology and using bacteriophage experiments. These are experiments you can do overnight very readily and so forth. And there were a lot of physicists who came in and did that. But the problem for physicists is they were often locked in to a particular conceptual framework. Biologists need to be very careful about getting locked into a conceptual framework that's rigid. You need to be prepared to shift. That, of course, is one of the problems that politicians and the general public has with scientists, because when the public listens to us, and the politicians too, the politicians want to be told something that they can really grab hold of and go and run with. The general public wants to be told. But what we tell them is, in effect, our best understanding is that. That's the best a scientist can say. We can't say, as Donald Trump does, this is the truth. We say our best understanding is that.
In your team, trying to find that best understanding, for example, people shifted from physics to biology. Have you seen all the modes of collaboration change throughout your lifetime?
Well, that's within a laboratory. And because we were working, I was always working with infections and immunology, bringing very complex systems together. We'd often divide up different bits of it in the lab, and people would collaborate. And so some personalities that didn't work for, but didn't really fit my lab model. And we'd kind of alternate authorships and so forth. Some principal investigators will have a particular project and they'll set two people on it to compete with each other. I think that's not a very good dynamic. Personally, it wouldn't work for me. So my lab was always fairly, hopefully collegial. It broke down once badly, actually, and it was because of two personalities that got head-to-head. But otherwise it was fine, and I've had some very successful people come out of that. On the other hand, the other thing that's become essential with modern biomedical science becoming so complex, and the power of molecular technology being so great, that you can't do everything yourself within one group. You need to collaborate with other groups, with other people, and often now a paper, which when I started out, you'd have 2 or 3 people on the paper, you'll now have 20 or 30. And in actual fact, on that research paper, there's probably no single individual who, though they may understand the principles behind the various types of manipulations that are done, there's no single person who's really across the whole thing totally. So the whole thing works on trust. And that's always a great fear, of course. A friend of mine has recently been caught in a situation where someone he trusted was faking data. And there were a lot of some high-profile papers published that have to be withdrawn. So that, of course, destroys the person who did it, but it also causes an enormous problem for the person who was running the lab.
Yeah.
So you've got to be very careful of that. And I was always tried to be, and so far, I think everything's okay, but who knows what might surface in the future. You never can be totally sure.
You talked about like a breakdown in relations between a couple of people in your lab.
Pure personality thing.
Yeah.
Yeah.
Just sort of generally speaking, what would you say was sort of one of the biggest challenges throughout your career, whether it's sort of in the lab or outside the lab?
Well, that was, that was a transient period, which was pretty unpleasant, but it was over when one of them left, essentially, and then gradually came back together again. I kind of enjoyed the lab experience. I love looking at data, like talking to young people. But I treat, basically, if they're starting to run with something, I let them go. And because what I've done largely, I haven't had a lot of graduate students, PhD students. I've largely worked with postdocs. And the postdoctoral period is supposed to be a transition period for those who have the talent between being a recently minted PhD, which is kind of the ticket to do research science, unless you've got a medical degree or something, and then maybe you don't need it, you can train in other ways, but generally the PhD is the ticket. So the postdoc's supposed to be a transition between that and becoming an independent person. Now, only a to actually run an independent research laboratory. Many people who graduate with a PhD are not going to make it. I mean, some of them slot in working as kind of super technicians, or they'll go into product development or industry or the regulatory agencies, for instance, or granting agencies. And we had a few of the people who came through the lab who went in that direction. But you do sort of get the sense of who's got it, who knows it. And really part of it, it's not necessarily the very most intellectual person in the lab. It's the person who brings together the qualities of focusing on the data, thinking about it, and who writes. Because my modus operandi in science has always been, it's actually to bring it together, and especially when I'm working with younger people where they're generating all of the data, really bring it together in my own head as I write it up. So one of the most important attributes for a young biomedical scientist is to be able to write. Some get around it. I mean, some people with different language backgrounds can work with professional writers, but I find the writing process brings a lot of my thinking together. So writing is another thing. But the other thing, which is absolutely essential, and this doesn't matter whether you're selling real estate or you're doing science, close it out. Some people will just go on forever. They can't bring themselves to finish something. I tell people to think in terms of the dog food model. Handy, bite-sized chunks.
I think it was Wittgenstein that said that you have to be prepared to kill your own babies, essentially. So if you're really close working on something, you have to be able to put it down and sort of know.
Yeah, if your idea is wrong, you've got to be prepared to kill it. And if you're, and I've seen very senior people unable to do that, and it's damaged them. If you get it wrong, and in something as complicated as this, it's quite possible your thinking will be wrong for a time. You've got to say, okay, we move on. Now, most successful scientists will do it. Most of them actually, if they get it wrong, they'll simply tiptoe away. I think it's actually useful for the process of science for people to say, to actually admit something and write something and say, hey, I got it wrong and this is why.
Yeah.
Most people don't do it though. They tiptoe away. And that's the point about science. I mean, people talk about reproducibility, they'll talk about all the rest of it, faking and all that sort of stuff. But basically, if it's fake and it's wrong, it just goes away.
I was looking at Empire, War, Tennis and Me.
That's a family story. That was it was a lot of fun to write. But you know, I'd written 7 books on various aspects of science and the scientific life. This was a family story I'd always meant to write, and with COVID, and I finally got around to it. I was going to retire at age 80, and then of course COVID came along right in my field, so I spent another 3 years intensively involved in science communication around COVID, and actually found it quite exhausting. But so yeah, Empire, War, Tennis and Me. I had a lot of fun writing that.
I don't know whether you've read any of Andrew Warwick's work. He sort of talks about sort of the physicality of sport and the physicality of science and sort of competing and combining those two professional and sort of hobbyistic things. Yeah,
I think, you know, the Second World War was immensely traumatic for us, Australia, and of course for Britain, and but the fighting to the north of us in Papua New Guinea and Borneo and so forth, and the experience of all those soldiers who were trapped in Singapore. Well, of course, many were British, and we know that wonderful movie, The Railway Man, for instance. And my uncle, one of my uncles, had that experience. Didn't come home in the end, but so that experience of and of course losing a son or a daughter or whatever, and but also the sort of sense of this threat. I think it's terrible to see this coming back in the Ukraine.
You just mentioned that you were sort of involved with the whole response to COVID and communicating it.
Yes. I wrote 120 weekly essays on it, called Setting It Straight, which went up on our website, a sort of blog, trying to sort of get the message across about the science. And eventually I had to stop because there was nothing more I could say. The science wasn't coming out quickly enough. It was complicated. And so eventually I stopped it. And I also was on Twitter a lot, which was good as a sort of means of discussion. And there was a lot of good stuff on Twitter, actually. People were putting up feeds where, some a research gynecologist or would look into the whole question of Twitter and of COVID and the neonate and the fetus, and put up a whole series of posts that would link it. So it was very useful. Then, of course, Musk took it over, and essentially it's been a very toxic site. I'm still on it because I do know that, and with many things, you get incredibly attacked. I've just taken to blocking people, actually, but you still won't get publicized here. And a lot of things don't get publicized here because our major media is controlled by that Muppet Murdoch and those people. And so anything that's not convenient to their view, which is toxic, may not ever be reported. So I do put up stuff, and if you see it being retweeted 50 or 60 times, then you think, well, someone's getting something out of this.
On the whole, do you find those sorts of tools sort of useful?
I think constantly about dropping it totally, and I would never start up on some other social media platform. I'd like to get back to writing, but I haven't been able to for a time because I've actually formally retired, and there was a whole lot of stuff in terms of personal business and things like that we just let go, and we're trying to put all that together at the moment, and so I'm really missing, actually, though, working on something. I've got an idea for a book that I really want to pursue, and that I like to write about things I don't know a whole lot about, actually.
Yeah,
because you learn from it. Yeah. I'm totally bored. I should write a book called, say, The Long and the Short of COVID-19, but the thought of it appalls me. Yeah. I may do it, but it might be a bit soon to do it anyway. I intend to keep writing books, even though, books are probably a blog post is a better way of communicating with people, really. But I don't want to do that. I like to write books because I like to synthesize a total piece of work. I mean, the thing about tennis, really, I never understood the war to our north. I'd never looked at the causes. I've always got to go, I'm a total academic. I've got to go in depth, dissect it, and try and ask, why did this happen? Okay, and what was the meaning of it? And so that comes, I hope, comes through in that tennis book. What was going on? Why was this the way it was? And it was very educational. Yeah, and I learned a lot from it. But I've learned a lot from all the books I've written, actually. So, except maybe the one that I wrote during the pandemic, An Insider's Plague Year, which isn't a real book. It's just bits of that blog post and a bit of background. But I say people I'm not very proud of that book, and they say, "Oh, no, we thought it was good." So,
yeah. I thought it was good.
Probably the one I'm most proud of in the science lineage is the knowledge wars. I thought, but as a philosopher, you might see a lot of holes in it. But there's a chapter on invented narrative and deliberate ignorance, which is a perfect description of Trump.
Thank you very much.
Okay. It's been nice to talk.
Yeah, you too.